Good morning. My research is population mapping using census data, GIS, and remote sensing. This research will be in 4 main chapters. First of all, looking for the errors in previous model, and then try to improve that for the UK by using secondary data, and then improve the model by using remote sensing for the area that secondary data is not available, and discuss that if this model can be used in another countries. The first chapter has been done and presented for my differentiation, so I will just skip the process and just very briefly explain why we need a graded model, population model, and what was the result. Graded population model is a raster data set that is capable of improving integration of population map with other georeference non-populated data such as physical, social, and environmental data layer. It's a pixel-based map that each pixel has a value, that this value represents the population for that particular area. And in this map, darker area, they have lower value. Graded population map can help us to analyze the impact of environmental changes on demographic condition of population, and also it can help to explain the changes in lifestyle and infrastructure development of the area. It can help to find out the relationship between population, health, and environment, and also studies of crime rates, transportation, and also emergency planning. They are highly rely on population map. And for example, if a natural disaster happens somewhere, we can estimate the casualties before getting there, and also we can follow changes through the time. For the UK, we have census point data that each point has a value, and this value represents the population for the postcode area. In current model, introduced by Professor Dave Martin, it's a kernel-based system. We try to redistribute population from each census point to the pixel around itself by using K and alpha parameters. Census point data for Northern Ireland has been used as the input data in that kernel system, and we try to redistribute them to the pixel base, and the result is this one, called global population for Northern Ireland. The higher, the darker area, it has the lower value. Also, the digital site boundary is available for each census point. So we can use this digital site boundary as a proxy to be sure that data from each point will be redistributed just in one area. So this digital site boundary has been used in the model as a proxy, and another map generated called local population map for Northern Ireland. So two maps have been generated, global and local, and also in the UK, uniquely for Northern Ireland, we have a graded population map that is available from 2001. And these two data will help me to compare generated data with the true data and find out the accuracy of the generated map. The result was just 40% accuracy in populated area for the local model, and just above 41% accuracy in populated area for the global model. And then ordinary least square, special correlation, geographically weighted regression has been done for both models, and we find out that actually the special location of the census point and also K and alpha has a very correlation with the error. So we try to improve this model for the UK by using secondary data. We knew that actually the assumption of homogeneity of this kernel system is problematic. We try to redistribute population from a census point without realizing that some places has from this pixel around it that has there is no population. It can be a river, it can be a green area, or some places with no population. So I'm going to use pointer data that as a proxy to improve the model. For each floor in a building, we have a point. And for example, if we have 10 floor buildings, we will get 10 points on top of each other. So it will let me to calculate housing density from the area. And 3 months working with R programming, Python, and using housing density to improve the model, actually I get to nowhere and no improvement in the model. So until I saw that, and I decide to, instead of improving the model, making a new model that's using advantages of the previous model and also has no problem in the problems that the previous model had. With the spatial joint analysis, I will be able to join point data, census point data, to the polygons around itself. So after that, I won't have the problem of the spatial location of the point, and this point will be actually belong to the whole polygon. House density calculated from the pointer data, and then this digital site boundaries comes on top of the housing density. So I will be able to calculate the total density per polygon also. By calculating total density per polygons, and also I do have house density, I can calculate by dividing housing density to total density, I can calculate the proportion of each pixels for the population. So just by simply multiply population to this one, I can generate a new map for the area. And now I'm going to check the accuracy of this new model with the true data. The accuracy in populated area was almost 90%. And to compare with the previous model, that's a global one, that it was just above 41% accuracy, and the local one was 40% accuracy. So this new model actually improved the result more than double. Other items for a statistical item calculated, and then move to the ordinary least square regression. We can see that there is a negative relationship between population density and error. So it means this model can work better in the area with more population density. And also there is a positive relationship between population variance and housing density. Adjusted R square calculated and shows that it's 70% and shows that the model has a good performance. VIF calculated to be sure that these independent variables, if they affect each other, and you can see that they don't affect each other. Probability and robust probability calculated, both of them statistically significant. So it shows that all independent variables helping the model. A special autocorrelation report shows that the model is clustered and is not randomly distributed. So I move to the geographically weighted regression and map the coefficient. And from here you can see that the performance of the geographically weighted regression is slightly better than the OLS model. The true data in Northern Ireland give me a very good opportunities to calculate the accuracy of different models. and improve the accuracy for the current model. Also, we can see that the accuracy improved in new model all more than double. And ABS, absolute error, calculated for the errors. And from here, we can see that from that percent error in the new model, most part of that is belong to the area that actually we overestimated or underestimated population up to 6 people, up to 6 people. So if we are working on some application that we do not need accuracy better than absolute error equal to 6, we can rely on this model even better. Both standard variation and housing density, both they had a positive relationship with the error. And for the pointer data that we use, we have a field that shows commercial, residential, and mixed. In this research, I removed the commercial data and just give the equal value to the residential and mixed point. However, if we could give the value to the residential and mixed area according to the bedrooms, number of bedrooms, I could get a better result, and it's about the standard variation and housing density. I could get better result. So I want to say that this model even is more flexible to improve the result in future with getting better data. Also, in this research, I'm looking for an alternative for the true data, that is population map that present population at night. However, people during the time, daytime, they are moving somewhere else, working, and the map for night and daytime should be different. And this model is capable to generate a new map for daytime also. For example, instead of removing commercial points from the pointer data, I can give different value to the commercial, the residential, and mixed, and also map population during the time. And for future research, I'm going to use secondary data for England, and also using remote sensing data for the area that secondary data is not available. And that's it. Thank you so much.
Thank you. Great questions.
Cool. I think you've almost answered my question, actually. I mean, obviously using the housing, the distribution housing, if you like, is a good proxy to getting away from these terrible coral pet maps, which show an even surface. But what I was going to say is that there's clearly going to be a difference in population density as expressed through houses, compared, if you like, with a block of flats to professorial leafy residences in South Belfast. But essentially what you're saying is that there are other data, so you can bring, well, I guess what I'm saying is what data are available to give you that weighting by bedrooms or whatever, weighting for a block of flats. That might have 1,000 bedrooms, let's say, where a leafy house in South Belfast might have 10 bedrooms.
Actually, at the moment, I haven't found yet any data that's showing the number of bedrooms. That's why I didn't use it and just give them the same value. However, we could use, for example, if we just with from the census data, or might be from the small research, we find out the number of bedrooms in each area. For example, might be in Lisbon Road, they have almost a similar number of bedrooms, houses in different areas similar. So might be we can use number of bedrooms in this way. And but at the moment, I haven't found any data that's giving me the number of bedrooms per buildings. And also we have another problem that is about some buildings that like student accommodation that in different times we have different population of them. We have another problems in places like hotels, and that's why we're getting almost 10% error on that.
Another question? Sure.
Could you roll it in reverse? You didn't work out what the number of bedrooms are for a particular area. So, for example, if your algorithm is running based on 2 people per bedroom in an area, and you get a good correlation there, and you know it's working well, then in other areas where it's not, you need to up the number of residents. You know what I mean?
Yeah, actually, that's the good thing that I'm quite happy with this model is this model is capable to use secondary data as much as we have and improve the result. But in the previous model, it's a very I tried to use even just the housing density, and after 3 months programming, I have no progress in the model.
Thanks, Ben. You spoke at length about your research question and your process and method. How might your research be used in public policy?
Population model, it can be used in different aspects. So in this research, we try to make as much as possible accurate population map. So different applications, they can use it. However, I think for development of the area, it can be used very much in this case.
Okay, thanks very much, Ben.
Thank you so much.
Thanks very much to all four speakers of this session for a set of very varied and interesting talks. Okay, copy now. Should be at the back there.